Have you ever really looked at a bridge or a skyscraper and wondered how it all holds together? Well, it all boils down to these simple but super powerful rules of lines and angles. In this explainer, we're going to pull back the curtain on these geometric secrets, starting from square one and building our way up to see how they literally shape the world around us.
So, here's the game plan. We're going to start with the absolute basics, the building blocks. Then we'll see how angles hang out with each other. After that, we'll introduce a real game changer, the transversal. From there, it's all about unlocking the rules and finally putting it all together to solve a real problem.
You know, it's so easy to think of geometry as just stuff in a math book, right? But it's not. It's the hidden blueprint for, well, pretty much everything you see. Today, we're going to learn the language of that blueprint.
All right, just like any language, you got to learn the words before you can make sentences. So let's get down the fundamental vocabulary of geometry.
Okay, first up, a line segment. Super simple. It's got a clear beginning and a clear end. You can actually measure this thing.
Next, we've got a ray. Now, this is different. It has a definite starting point, but then it just goes on forever in one direction. The absolute best way to think about this is a beam of light from a flashlight. It starts at the bulb and just keeps on going.
So, what happens when you take two of those rays and have them start at the exact same point? You get an angle. That shared starting point is called the vertex, and we measure the space between the rays in degrees.
Okay, so we know what an angle is, but here's where it gets really cool. See, angles almost never just exist on their own. They usually come in pairs, and these pairs have these really special, totally predictable relationships.
And it all comes down to two magic numbers, 90 and 180. Complementary angles are two angles that team up to make a perfect 90-degree corner. Supplementary angles, on the other hand, team up to make a perfect 180-degree straight line. Easy way to remember? C for corner, S for straight. Now, think of adjacent angles as next-door neighbors. They share a wall, that's the common arm, and they share a corner of the property line, which is the common vertex.
And when those neighbor angles, those adjacent angles, arrange themselves so their outside arms form a perfect straight line, well, that's what we call a linear pair. And because they make a straight line, they're always supplementary.
Okay, this is a big one. Write this one down. When any two straight lines cross each other, they make an X. The angles directly across from each other in that X are called vertically opposite angles. And here's the simple, powerful rule. They are always equal. You will use this one all the time, trust me. All right, we've got the basics down. Now, things are about to get really interesting because we're going to introduce a special line that comes in and slices across others. This line cutting across is called a transversal. And when it cuts across two parallel lines, two lines that are like railroad tracks and will never ever meet, something kind of magical happens. It creates this perfectly predictable pattern of 8 angles, and that unlocks a whole new level of geometry rules. So let's break down the key relationships that pop up. We're going to look at corresponding angles, alternate interior angles, and consecutive interior angles. I promise, once you get these three, you can solve pretty much any problem involving parallel lines. First up, corresponding angles. The name kind of gives it away. They're in the same corresponding spot at each intersection. So look here. See how angle 1 and angle 5 are both in that top left position? When the lines are parallel, these guys are always equal. Next up, alternate interior angles. Again, the name tells you everything. Interior means they're between the two parallel lines. Alternate means they're on opposite sides of the transversal. So like angle 4 and angle 5. And yep, these are also always equal.
And for our last key pair, we have consecutive interior angles. They are interior, so they're between the parallel lines. But this time, they're consecutive, meaning on the same side of the transversal. Now here's the twist. These are not equal. Instead, they're supplementary. They always add up to 180 degrees.
Okay, this slide right here, this is your cheat sheet. It puts all three of those big rules in one place. You've got your corresponding angles that are equal, your alternate interior angles that are equal, and your interior angles on the same side that add up to 180. Seriously, this is a great spot to pause if you need a second to let it sink in. This is the key to everything that comes next. So we've learned the vocabulary, we've unlocked the rules. Now for the fun part, the payoff. Let's actually use what we know to solve a problem. So here's our challenge.
But before I walk you through it, I really encourage you pause the explainer right here and give it a shot yourself using the rules we've just talked about.
All right, you ready? Let's break this down. The first and most important clue is right there in the question. POQ is a line, a straight line. And if we look at the picture, we've got 3 different angles all sitting together on that line.
So the absolute key here is to connect what you see to a rule you already know. Angles on a straight line. What does that mean? They're supplementary. They form a linear pair. So their sum must be 180 degrees. As soon as you know that, you can build the equation 40 plus 4x plus 3x equals 180. From there, it's just a matter of solving it step by step.
And there you have it. Just like that, by simply finding the right rule for the situation, the answer pops right out. X equals 20 degrees. See, every one of these problems is just a puzzle, and you just need to find the right rule to unlock it.
We've solved the puzzle on the screen, but the real test and the real fun starts now. Start looking at the world around you differently. Look at the frames of windows, the pattern of railway tracks, the design of buildings. They are all built using these exact rules. You now have the tools to see the hidden geometry that holds our entire world together. So what patterns are you going to discover?